Hello, calculus students. I wanted to go over this worksheet on maximum and minimum values. I'll let you read through the definition of absolute. Well, we can do it together. It says, let C be a number in the domain of D, actually the domain D of a function f. Then f of C, so notice that's the y value, is an absolute, or sometimes called global, maximum value of f on D if f of C is greater than or equal to f of x for all x in the domain. So that just means it's the largest or the highest y value in the domain. Absolute minimum of f on D if f of C is less than or equal to f of x for all x in D. So it's lower than any other y value. And that's what we're going to be looking for today. Now, we also have f of C as a local maximum, so it's high in the neighborhood. And this is on this domain if f of C is greater than or equal to f of C for all x near C. So it's just in the neighborhood of that x value. You have a high point. So let me show you over here. So this right here, let's say that's a local maximum because it's high in this neighborhood. Over here, this is a local maximum. This would be a local maximum if it existed, okay? Because in that neighborhood, it's a high point. This is a high point, and this is a high point. Absolute maximum means it's the highest point on the entire graph. So you'll see that that's an absolute maximum. Nothing is higher than that point. So your local maximum is x near C, so in the neighborhood, and a local minimum of f on this domain if f of C is less than or equal to f of x for x near C. Now, let's take a look here. It says use the graph of f of x to find all local and absolute extrema. So we're going to do that. So let's look at local maximum. That's kind of a minimum, maximum, minimum, maximum, minimum, maximum. What is that? It's kind of a high point, and this is a low point. However, those are undefined, so that'll be a problem. So let's take a look at local maximum. This is a maximum, but it doesn't exist, so that's not considered a local maximum. Local min, local max, that is a local maximum because it exists and it's a high point in the neighborhood. So we would say that we have a local maximum of 5. And then down here is a local min. Here is a local maximum of 4. This would have been a local maximum had that point existed, but because there's a hole, it's undefined. So what are the local maximums? I will write them over here. Our local maximum is at 5, or the local maxima, plural, is 5 and 4. And notice that we're giving the y values. Now the absolute maximum is 5 because that's the highest point on the graph. Local minimum. Let's take a look at this graph again. Local minimum. Let's see, that's a minimum, 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 minimum. This is not a local minimum because it is not defined to the left. So we can't say that we don't know what's going on over here. This is a local minimum because it's a low point in this neighborhood. And this is a local minimum because it's a low point in that neighborhood. This is a low point, but it's undefined. So our two local minimums are here. And we say the local minimum is 2 and 3. So you'll see that I've written that here. Pardon my shakiness here. The local minimum is 2, 3. And the absolute minimum, there isn't one because there is no absolute lowest point. This looks like the absolute lowest point, but it's undefined. It would have been if that had been solid. So we would say there is no absolute minimum. Now, I'm going to go ahead and go to number 2. Yeah, let's do an application of this. I'm going to go ahead and pause this and come back and take a look at number 2.